Okay, good morning, Year 9. Sorry that I'm not live with you for today, but we are going to do angles inside polygons today, also known as interior angles in polygons. This is something you have done before, but it is something that students sometimes tend to find challenging to retain, so it's worth us revising. So the first thing I'm going to do in this first little video is show you how to calculate total interior angles. So, first of all, we're going to imagine a triangle, standard triangle. We know that a triangle has 3 sides, and we know it has 180 degrees inside. So I'm then going to go to a quadrilateral. It actually doesn't matter what quadrilateral I'm talking about. Oh, hopefully we'll keep focused. Doesn't matter what quadrilateral I have. It doesn't matter whether I draw a rectangle, a square, a trapezium, or an irregular one. We'll talk about regular versus irregular shortly. But I know that a quadrilateral has 4 sides. And I also know that it has 360 degrees. These are just facts that I know. Might be helped by the fact that with a quadrilateral, I can split it into 2 triangles. I could split it up more, but then I'm creating angles in the middle of my shape, which I don't need. I'm just going to see if I can. There you go. Looks like it will focus more, hopefully. So there's no point me drawing more triangles. All I want to do is make sure that one point actually meets up with every other point in the shape. So I'm now going to take a pentagon. Again, it doesn't matter whether it's regular, irregular. A pentagon has 5 sides. Now, how many angles do all the angles of a pentagon add up to? Well, I can split a pentagon up into 3 triangles, where all the angles are at the angles within the pentagon as well. So I've got 180 degrees here, I've got 180 degrees here, and I've got 180 degrees here. So if I add these together, my pentagon has 540 degrees. Because I've been able to split it into 3 triangles. I'm going to do the same for my hexagon. I'm going to take a corner and join one corner up to every other corner that it's not already attached to. So a hexagon has 6 sides, and I can split it into 4 triangles. So again, each of these has 180 degrees. So 4 lots of 180 is 720. So if I look here, I did 1 lot of 180 for the total interior angles of a triangle. I've done 2 lots of 180 for the interior angles of a quadrilateral. 3 lots of 180 for the interior of a pentagon. 4 lots of 180 for the interior of a hexagon. So this pattern is quite clearly going to continue. So let's propose I have a shape that has n sides. So I don't know how many sides this shape has got. How many triangles does it have? Well, if we look at these, it has 4 sides has 2 triangles, 5 sides has 3 triangles, 6 sides has 4 triangles. So the number of triangles contained in an n-sided shape must be n subtract 2 triangles. So what about its total interior angles? Well, here I did 2 lots of 180 when 2 is the number of triangles. Here I did 3 times 180 where 3 was the number of triangles. 4 times 180 where 4 was the number of triangles. So I take the number of triangles and I times it by 180. So the total interior angles of a polygon is found by doing n minus 2 times 180 degrees, where n is the number of sides or angles of the polygon. So you should know this, you should remember this, you're not going to be given it in an exam. And this will allow you to work out individual angles inside a shape. So what I want you to do now is going to watch the next video where we'll actually apply this to some different questions.